So you can go to draw.io and you have this flowchart and online diagram maker. So you can create diagrams using this. This is a pretty good tool. And in fact, you can download a copy of it and you can use it on your system as well. So is it visible? The diagram is visible on to every one of you? All right. So this was a diagram that I showed in the demo class where I had created kind of you can say step-by-step process on what we need to do to create, I would say, AWS services and what are the AWS services that we use. So in a region, we need a VPC. As of now, whatever EC2 instance that we have launched, it was in a default VPC. So default VPC is the VPC which is available by default. Keep in mind, default VPC, if you spin up any EC2 instance in default VPC, it will have a public IP attached to it. Okay. It's not the case for a custom VPC. For custom VPC, you need to enable that feature. Okay. So in a VPC, we have subnets. Now, as VPC is part of the region, subnets are part of availability zone. So we will have different subnets in different availability zone. And then we can configure EBS volumes and EC2 instance into each availability zone as we require. And going forward, what we will do, we will continue this kind of diagram and we'll continue implementing all part of this. So we have seen only this part, EC2 instance and EBS volume. We have seen some of lot of functionality of both of them. But next part would be in advanced EC2, we have to use an auto-scaling group. So this is an auto-scaling group in a multi-AZ environment. So multi-AZ environment means we have EC2 spread over multiple availability zones. So this icon is for availability group. This icon is for auto-scaling groups, not availability groups, auto-scaling groups. And then this is your load balancer. So load balancer is basically, if you see these three kind of offshooting from one box, this is load balancer, which is basically telling this node is sending requests to multiple AZs. This is route 53, and we have seen only one entry as of now, a entry that we did right now. But we are going to cover route 53 in detail in the next sessions. And then this is the database. So the database part, I have a master and replica database here in different AZs. So we are going to talk about this when we are going to do RDS. So right now, what we are going to do, we are going to spin up a new VPC, right? And we are going to use a subnet here, supernet that we are going to decide upon. And then we are going to assign subnets to rest of the availability zone, right? So let's get started. And for this, I'm going to go into a different region. So let me go to Sydney. You can do it anywhere, but you have to make sure that whatever you do on your AWS account, make sure you clean it up. All right, now I will go to VPC. And I think I've told you there is a default VPC in every region. So this I've created before. Let me go to another region. Let me go to Singapore. Okay, so in Singapore, there is a VPC, and this is the default VPC that it's already present. And this is with this CIDR 172.31.0.0/16, which is basically a class B IP address, right? So we have classless IP address and classed IP address, right? Classful IP address where you have different CIDR notification. If you're not from networking background, don't think much about them. Think of it as we need IP address to assign to our host. And I have attached some slides which cover a bit of basics of IP addresses as well as part of reading. Now, what we are going to do, we are going to create a VPC, right? So click on VPC and more. So the first option is VPC, but there is a good option here, which was not previously present, which is VPC and more. So now with this, you would be able to create all the VPC as well as subnets, etc., whatever is required, the complete infrastructure in one go. All right. To do that, let me open a notepad, and what I'm going to do is, so now let us name this VPC as a bootcamp VPC. Okay, and let me take one IP address 10.0.2.0/16, which means /16 means this octet and this octet I can assign for host. This will be fixed. Okay, so every dot notation means 8, right? So if I have /24, this means this part is fixed. If I have /16, this means this part is fixed. So this means for our VPC, this is not going to change. Now there is a very good tool which I would recommend, is a visual subnet calculator. Okay, so let me reset it. And if you use 10.0.2.0.0/16, is it visible clearly? So there is an option where you can
Yes,
put your network address and define the subnet mask and click on update. So you'll have the subnet address. Now we can divide. So you can divide the network. This is subnetting. Basically, you are creating sub networks from this complete network address. Now it's up to us how much we divide. So I will just keep on dividing where I have a consistent number, and I will be using /20. So you can keep anything, it's up to you, depending upon how much you want. Now with /20, you see we have 4,000 hosts in this network. This means if every EC2 instance that we spin up takes one IP address, I'm able to spin up around 4092, you can say host, 4094 host, uh, because the first .0 and .255 is not usable. So the usable IPs are .1 and .254 in the last octet. So I can have 4094 hosts, right? So which are more than enough. So what I can do, I can copy this complete table and keep it as a reference. So generally when you design a new VPC, you would need to create a subnet, and then you would divide all this subnet into, you can say, more subnets, smaller subnets, and here you will have subnet address, the range of address, and then host, and then you can assign it. So now let me just remove this part. Just use it here. I'm just making it editable. So what I can do, I can just remove all this on, you can say, host here, and I will just put remarks. You can do it in Excel if you want. And for the first three, I would say public, right? And AZ, and then I can assign AZA, AZB, and AZC. So this means I'm assigning 2.0.0/20 for public subnet for availability zone A, or you can say AZ1, AZ2, AZ3, whatever you want. Now, what I will do, I will assign the next one of them for private subnet in AZ, and I can assign AZ1, AZ2, and AZ3. Now I have all these IP address. I can just mark it as future use. So in case you want to have one more private subnet, you can create this. Suppose your requirements go that you need to have one more public subnet, you can use these, or you can assign IP address depending upon your requirements, right? Any question in this, what I did right now? Don't need to worry about that this much. This is for understanding. There would be no questions that you have to subnet, or you can say create this subnet, but this is just a preparation for creating a VPC. All right. So now what we did, we initially created a bootcamp VPC design where we have selected a kind of subnet address for my VPC, and then I've specified the IP address. So now let's go to our VPC part. Now we are creating a VPC, and we are going to, you can click on auto generate, or you can, remove it. So I can create a tag here. So what would happen? Whatever subnets and everything is creating, if I click on auto generate, it will tag them with that name. So let me just create it as bootcamp VPC. So you can see it is automatically creating bootcamp VPC root table, bootcamp VPC private one. You can say root table here, and private to root table. So this is a public root table, and this is a private root table. So right now it has created, you can say it is just showing the subnet for two VPC, two AZs, AP Southeast 1A and AP Southeast 1B. So here we have to specify the CIDR, and what is the CIDR that I'm using? This one. So I can just copy this, go back and put this CIDR. Okay. You can also assign an IPv6 CIDR if you want. So, but for that you need to use, you can say Amazon provided, or you can have on your own IPv6 CDR. Now this is a tenancy. You can have a dedicated tenancy or default. I'll go ahead with default. Number of AZs you want. So I will select 3. So now you can see it will show you that it is going to create 3 and 2 subnets in each VPC. The green one is the public one and blue one is the private one. All right. It differentiates in the term of color as well, green and blue. Green is the public one and blue is the private one. Now number of public subnets 3, number of private subnet you can have 6. As I mentioned, if you want to increase, so that's why we have some IP addresses for future range. But let's start with the 3. Now you have to customize the subnet. What happens, if you put the CIDR here, it will automatically generate some CIDR. You have to check if you want to use this or you want to use something else. So for example, public subnet in 1A, 1B, 1C, it's 0.0, 16.0, 32.0. 0.0, 16.0, 32.0. Yes, this is correct for public AZ1, AZ2, and AZ3. But for private, I think it is different from my design. So I will just copy this. All right. Now you need to select NAT gateways. So NAT gateways is basically, if I go back to this diagram, right? So this NAT gateway will help you, connect to the outside world. So it's not being shown here, but NAT gateway is different than this is the internet gateway. NAT gateway is for the outside connectivity. Basically, it converts your private IP addresses to public and from public to private. All right. So we can have only one NAT gateway, or we can have one per AZ. This means you can have 3 NAT gateways, one for single AZ. I don't want to pay much, so I will have one in single AZ. Then you have VPC endpoint. So basically, for internal AWS services, if I want to connect, there are 2 ways. I can go through the public internet, or I can connect directly. And for that direct connection, for example, I want to connect to the S3 bucket. What I can do, I have to create a VPC endpoint here, which would basically, if I draw the diagram, so it will connect to that S3 endpoint. So this is the VPC endpoint that we'll create. So this means all the S3 buckets would be sending data from this S3 endpoint. So S3 endpoint is a special network interface which would connect only through the S3 buckets. Okay, and then you have to this option either enable DNS host names and enable DNS resolution. So this is not for public one. This is for internal one. For example, you have your EC2 instance. For example, if we see this EC2 instance, there is a private DNS as well. So what would happen? Like for example, this is the private IP DNS name, IP this compute.internal. If you enable this, you would be able to reach to other EC2 instance or other resources using this private DNS. Okay, so we can create it, and if you want, you can provide additional tags and just create VPC. So what it will do, it will create the VPC for you. It will enable the DNS hostname, DNS resolution, and it will do all these things. So you can see here how much steps you need to perform to create a VPC, and this is all automatically done. So it will create an ad gateway, it will allocate an elastic IP address, it will create a route table. So all this is kind of preparation that you need to do for to run your you can say workloads. Now this is pretty logical, and if I come back to this diagram, so we are in region Singapore. What we are doing, we are creating a VPC, right? This is the VPC endpoint with a subnet that we have selected. This is 10.2.0.0/16. Okay, so here this is 10.2. So higher the subnet that you choose, for example, if you select /24, you won't have that much of IP addresses. Then we are creating this public subnet, right? So we had associated some IP address for public subnets and also for private subnets. So this is for private subnets. And if we go here, so it has created subnet. So 6 subnets, 3 public and 3 private. It has created an S3 endpoint. So this is the internet gateway, which I talked about. So this is the internet gateway, which is going to, help us connect to the internet, right? And it has attached the internet gateway to the VPC. It has also created route tables. Route tables are basically, to manage the routes. And now it is associating the route tables. Now it is creating a NAT gateway. So what happens for NAT gateway? You need a public IP address, because that public IP address is going to, translate to the private IP address and so forth. So this is the new elastic IP that has been associated with our account. So all the connections, outward connections, will be going from this, you can say, public IP. And this is associated to one NAT gateway, which is this one. And this NAT gateway will be in a single AZ. So this means it is not resilient. In case the AZ goes down, my NAT gateway would be deleted. My NAT gateway would be enabled, not deleted, would not be working, and I would face some issues. Now it has created route table. So if you see this route table, so you can see there would be some routes, and this is all the traffic going to NAT. So this means all the traffic from the private subnet, right, in the private route table, it is sending to the NAT, right? So outward connection is going to NAT, okay? And then you have the complete S3 endpoint created as well. So these are the resources that has been created. So now if you go to VPCs, and if I refresh, you can see there is the bootcamp VPC created. You can see the resource map. You have all the resources here, right? So these are the subnets in a different AZ. So in subnet 1A, you have, this is the public subnet. How many available IPv4 address? 4090. So why there is a difference? We had 4094. Why we have 4 IP address missing? Any question? Any suggestions here? Where are the 4 IP addresses? Why Amazon is showing 4090 and why our calculation tells us 4094? Because if we are submitting, right, we cannot use the first and last, because the first one is the network address and the last is the broadcast address. Usable IPs should be 4094, but Amazon is only showing 4090. It is using those 4 IP addresses somewhere else.
Gateway in the broadcast for each
It
subnet.
is, for each subnet there would be some DNS, some DHCP kind of requirement, which is used by VPC.
Mm-hmm.
And I will give you the details here. But yeah, you're partially right. It is using it for broadcast and all these things. But yes, you can see the details here. The outward traffic from the public is going to internet gateway. From the public, where the traffic is going to the internet gateway. And from the private, It is going to the NAT gateway. Any questions? This is important. From the public, your traffic is going to the internet gateway. 000 means all the routes are going to internet gateway. From the private, it's going to the NAT gateway.
Can you please show me that diagram? Okay. So what is significance of this public and private here inside the VPC?
Okay. So significance is this internet gateway is basically you are connecting everything directly,
Hmm.
right? So this means anything here, internet can access all these subnets directly.
Okay.
Okay. You will not be able to access all these instances directly.
Mm-hmm.
So what would happen? There would be an ad gateway. So if I create an ad gateway here,
Okay.
so you will have an ad gateway here. So this will go to an ad gateway, and this NAT gateway will go to this.
Yeah.
So this NAT gateway will sit in between.
Yeah. So this private subnet, how can it connect directly to the internet?
So it won't be able to connect directly. So it will go through NAT gateway. That's what I'm saying. It will go through the NAT gateway. Think of it, NAT gateway is only for outbound connections. You
No,
would
no.
not
So
be able to,
in case of the public, our IPs are still the private IP. So how will it connect directly with the internet?
no, for public, what would happen? There are two ways. Okay. One is you whatever you spin up here,
Yep.
you won't be able to access directly until unless you provide a public IP address.
Yes.
So what we will do, for example, if you put a load balancer here, we will assign a public IP address to it,
Yeah.
and it will you can access it directly from the internet. But
Yep.
what we are going to do, we are going to assign a public IP address to the resources in the public subnet. So think of it, any resource that we put in public subnets, we have to assign a public IP address or we need to map it to a domain name.
Yeah.
Until unless it's one and the same thing, the public and private subnets would be the same, right?
Yeah. Yeah. So that was my confusion. All good.
Yeah. So as you can say, Pradeep mentioned, right? The only difference in public subnet is we are going to assign public IP address, or we are going to connect it to the public domain, or we are going to, make it available from the public outside world. All the resources that are internet facing would go to public subnets. All the resource that you don't want to, face the internet will go to the private subnets. Okay. Any questions or confusion here? So just a let me just open that tab again where it is. Yeah. So just a reminder, if you're going to don't try to spin up this VPC, because though there is no cost in the VPC, there is a cost in NAT gateway and the S3 endpoints. So don't try to do this because it would be very difficult for you to clean it up. uh, it is not easily directly clean it up. You need to first delete S3 endpoint, delete the you can say NAT. So it would move from right to left. Once you delete everything here, you can delete everything here, then you have to delete everything here. So it is very tedious. So go through the video, understand how it is being created. Next week we also will take flow logs. Flow logs is something like Wireshark, where we will check what traffic is going on, and I will show you how to capture those logs and how you access those flow logs. So that flow logs is something like packet capture that you do on Wireshark. So I think that's it for today. Any question related to VPC?